to understand in algebra is the way that equations can be represented in a lot of different ways. So we can obviously represent equations with equations, y equals mx plus b, or something of that nature. We can also use tables to show what the values are, and we can use graphs. And all of those work together, right? So the table can show us what the graph looks like. The graph can tell us what the equation is. We can go straight from the table to the equation. So all of those things work together. It's called multiple representations. It's something that we talk about a lot whenever we talk about like math teacher training sort of stuff. Is we want you guys to understand that the table, translates to the graph, it translates to the equations, and they all work together. So today we're going to look at that a little bit, and to do that, we're going to start off looking how the table goes to the graph, and then looking at that as far as the equation goes. So the first thing we're going to do is just plot these points right here. So 0, 2, we're going to plot that point 0. We go over 0 and up 2. Yep. So x-axis is here, y-axis is here. So we go on the x-axis, we don't go anywhere because we got a 0, and then on the y-axis we go up 2. Then we have 1, which 1 would be right here, 6, which is right here, 2, 10. The rest of our numbers are too big for our graph here. So we can't graph those, but we can see from the pattern here, we could even go and continue this pattern on and fill in these points here to graph us a line that looks like this. So we have been practicing looking at graphs and equations. So if we're putting this in y equals mx plus b form, then for our equation here, let's see, Hank, what would the equation of this line be? Like the plus 2. The 1 over 6 is not going to be correct. So whenever we're doing that slope, we're starting at one point and going to the next on the line. So how many do you go up or down here? 4, and then over 1, right? So it's just going to be 4. You can write 4 over 1 if you want, but 4 over 1 is just 4. Okay, so what we want to be able to do is, of course, we want to be able to go from a table to a graph to an equation, but we also would like to be able to go straight from a table to an equation, because we're going to start to see some where we're not going to be able to graph them because our numbers are too big, and some where we don't have the graph there for us, so it's going to be harder to graph them. So let's start to think about how we could go from the table to the graph. So one thing we've already done is look at slope from a table, right? So when we did slope from a table, so we were trying to find the slope without looking at the graph. If we pretend the graph is not here, how did we find slope with our table? What do you think, Jada?
Well, if you could find the y-intercept by doing
Okay.
Wherever the 0 is.
Wherever what is 0? Okay, so this is not the slope. This is the y-intercept, but we'll go ahead because we're going this direction. When x is 0, this is your y intercept. And if you think about graphing it, if you graph something that has an x that's 0, you don't go left or right any, then you go up or down, however many that is. So it has to be on the y-axis, right? So this is very good. This 0, 2, that's where our y-intercept is, right? So the 2 is our y-intercept. So when we're writing equations from a table, we want to look for where x equals 0, right? Because that's going to give us our y-intercept. So now let's talk about slope.
We already did that, didn't we?
We did already do it.
You added the 2 plus, or 6 minus 2 is 4, and then 1 minus 0 is just 1, so 4 over 1.
Yep. So you could like actually do slope formula, or you can look what's happening between 2 and 6. You're going up by 4. What about 0 and 1? Yeah. That's just up by 1, right? So my change in y over my change in x is y is over here on the right hand side. That's 4. Change in x is 1. And if I check everything else, I'm going up by 4 every time here. And going up by 1 every time here. So there our slope is 4 over 1. So that's another way we could get straight to this answer. Okay? Questions? All right, try this next one. It'll be halfway between 1 and 2. Okay, so graph these points for me. Okay, so we should end up with a graph that looks like this. So Wade, whenever we look at this one, what is our y-intercept? -2. So our y-intercept is -2. And I can tell that from the graph, but I can also tell it from this right here, where my x equals 0. That means this number is my y-intercept. Okay? All right. Ayla, what's the slope of this line? Okay? So, sometimes it's pretty hard to tell from the table. Look over here at the graph. Let's just don't look at every point. Just look at like the ones that hit on grid lines. Right here, Marley, what is our slope going to be? It's going to be 1/2. We're going up 1 to the right 2. So our slope is 1/2. Okay, let's look at how we could do that from the table. Okay, so sometimes it's difficult whenever you're dealing with negative numbers to see what's happening. So let's start down here where the numbers are positive. Okay, when I go from 0 to 0.5, what am I doing? I'm going up 0.5. Right? Is that what I'm doing here? From negative 0.5 to 0? Same thing, right? So sometimes it's easier to see with the positive numbers if you have any there. So you're going up 0.5, so you got a positive 0.5 for all of these. And what is happening over here on the left side? Where are you going up by? 1. So our slope would be our change in y, which is on the right-hand side, your y column, over your change in x, which is positive 0.5 over 1. But positive 0.5 divided by 1 is just 0.5. 0.5, you can write it as 0.5 if you want, or you can write it as 1/2. So either one is fine. 1/2 is what we've been more accustomed to. So we do 1/2 x minus 2. Or if you write it as 0.5 x minus 2, that's fine also. So you could either do this one or this one. Okay, questions? Okay, this time we have no graph, and I don't want us to have a graph. So we need to know slope and y-intercept. So let's start with y-intercept because I think it's easier. Sometimes it's easier. Sometimes it can be hard. So Zane, what is our y-intercept for this table? Okay, where'd you get the 1.5 from? Okay, that is something we're going to do that's going to help us find slope, but it's not our y-intercept. So we are going to do that eventually, but it's not our y-intercept. Easton, what do you think? It's not 4.5. 4.5 is that first entry right there, but that's not our y-intercept because if I graph it, it's at negative 5, 4.5. That is not on our y-axis. Okay, Ayla, what do you think? It is 7. Okay, Ayla, how can we know that it's 7? Right, x equals 0 right here. So when we're doing y-intercept, that's what we're looking for, right? So if x equals 0 in our table, then the y value that goes with it, that's your y-intercept. So that's what you're looking for whenever you're finding your y-intercept. So our y-intercept here is 7. And if you think about graphing that, you graph 0, you go up here to 7, you put a dot, it's going to be on the y-axis, right? So that's y. That's going to be our point. Now, whenever we look at slope, we're looking at our rate of change. We're looking at how the values are changing, right? So, for the ones we've seen so far, we were going up by a fixed number, right? Like we were going up by 3, or going up by 0.5, or we were going, you could even go down by 2 or something like that. But, if I go from 4.5 to 6, Zane's already told me that's going up by 1.5, right? Do I go up by 1.5 the next time? No. Or the next time. It's different every time, right? So, what we need to know is this a constant rate of change where we have a slope? Because if it's not, then we just can't write a line at all. Or is it not? So, the reason this may still be linear, even though it's not going up by the same amount, something that is linear has a constant rate of change. Constant rate of change is going to mean that it increases the same amount for each value of your y. So like something that goes up by 3 on the y's and goes up by 2 on the x's would be constant rate of change. But this one, my x's don't go up by the same amount either. right? I'm going -5, -2, 0, 1, 4, 5. They're going up by different amounts also here. So, Zane, from 4.5 to 6, I've got 1.5. I also have to consider my x. So, how much do I go up there? From -5 to -2, how far is that? Okay, it's up 3. All right. So, if I do for this one, let me slide this over here so I've got some room. If I do this one, I've got change in y over change in x. So that's y is on the right-hand side. That's 1.5 over 3. What is 1.5 over 3? It's 1/2 because 1.5 is half of 3, right? So we got 1/2. Let's check right here. Okay, Julian, how much does that go up by? 1. How much do the x's go up by? It's 2. Good. So from -2 to 0 is 2. So for this one, my slope, my change in y over my change in x is 1 over 2. Still the same, right? And so maybe we want to check this one. Okay, Vince, how much do we go up by when we go from 7 to 7.5? All right, what about from 0 to 1? 1. And so change in y over change in x would be 0.5 over 1. And that is 0.5, but 0.5 equals 1/2, right? So we're still getting that 1/2. We'll have some problems where we're going to need to check every single one of these because it might tell us it's not it might tell us that it might not be a constant rate of change. But for the first stuff that we're going to look at, it's going to be a constant rate of change. So I'm feeling pretty confident here 1/2 is my slope. So if my slope is 1/2, then Alyssa, what's the equation of the line going to be? Perfect. Make sure you put that x next to your 1/2. You have to have it there. Yes?
Can you go over one more time how you got the slope? I mean, you don't have to go to the full thing, but to the point where it's 1.5 and 1.
Okay, so you got 1.5, 1, and like down here it would go up by 0.5. You could keep going. It's going to be, here's another 1.5, and here's a 0.5, right? And then, so you're looking at how much you're going up by. You're going to do the same thing over here for the x's. So from -5 to -2, that goes up 3. And then here we go up 2, up 1. This one, if we looked at it, would be up 3. This one would be up 1. All right. So whenever we're looking at slope, it is the change in our y, our rise, how much we go up or down, over our change in our x, how much we go left or right. So, so the y column is over here, so it changed 1.5, right? So we're rising 1.5, and then the x changed 3. We run 3, so over 3. So we do 1.5 over 3, and since 1.5 is half of 3, that's 1/2. And then same thing here, 1 over 2 still gives us 1/2. 0.5 over 1 still gives us 1/2. If we did this one, 1.5 over 3 is 1/2. 0.5 over 1 is 1/2. So we have that constant rate of change of 1/2, which is going to be our slope. Does that help? Okay. So this is our answer right here. Okay, questions? All right, let's look at this one. Now, I gave you a graph again on this one for a reason here because y-intercept thus far has been our easiest one to come up with. What's the y-intercept on this one? We're going to have to figure it out. Because does x equal 0 anywhere on my table?
No.
X does not equal 0. You might be tempted to say over here, oh, I see a 0, so it must be 2. But that is where your y equals 0. So that is not the case. So what we're going to have to do here is we're going to have to start with the slope. Okay? So, because we can't find the y-intercept. So, let's think about our slope. So, Caroline, to go from negative 6 to 0, what am I doing there? Up 6. Very good. And then, Passion from 0 to 4. Up 4. Good. Vince, 4 to 6. Zane, bring me your phone. I was going to make y'all put them up there. I forgot. Thank you. And then, Zane, tell me how much you got to go up to go from 6 to 12.
6.
Good. And Cameron, what about 12 to 16? 4. Okay? All right, so those are all my changes in y's. Notice they're all different. But that's going to be okay if our x's are different. So, Presley, from negative 1 to 2. It's not 2. If you're thinking like number line, negative 1, 0, 1, 2, you start right here. You got to go 1, 2, 3. It's kind of hard sometimes when it goes from negative to positive. So we go up 3. Let's see. Hank, from 2 to 4.
2.
Owen, 4 to 5. Peyton, 5 to 8.
2.
Nope.
3.
Yep. And Katie, 8 to 10. 2. So, what you're going to do here for your slope is you're going to take each one. It's got to be your change in y over your change in x. So, right here, I've got 6 divided by 3. Right? Which is 2. 3's on the bottom, so it's going to be 2. You can do 2 over 1, but just 2. For the next one, I would have 4 over 2. 2. Over here, I got 2 over 1. Still 2. Looking pretty good, right? 6 over 3. 2. 4 over 2. 2. If the problem tells you it is a line, you don't have to check every single one of these. You technically could just check one to make sure you get that slope. So I've got a slope of 2. So, if you have something like this, you got a couple options. You could graph it, or you could make you a table to fill in. So I'm going to show you on this one what you want to do if you're going to graph it, and the next one, I think it's the next one, we're going to look at the table because we're going to have no graph. So, if I want to look at the graph, I have a bunch of points here I can graph. I've got negative 1, negative 6, which is right here. I've got 2, 0 here. I've got 4, 4. No, that's not 4. 4, 4. I've got 5, 6. 8, 12 is not going to fit, so I'm going to stop there, right? So if my slope is 2, that's a 2 over 1, right? So from each one of these points, I need to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I could also go down 2, left 1, down 2, left 1. And so when you fill that in, right here, we have our y-intercept. And what is that y-intercept? Negative 4. So our y-intercept is negative 4. So Passion, how would we write our equation? We have a slope of 2 and a y-intercept of negative 4.
2 over 1 x plus, or just negative 4?
I would just do.
No, there's no negative 4.
I would just do a minus 4. It's correct if you do plus negative 4. It just looks a little more confusing. So you can just do a minus 4 there, and you can put your 2 over 1, but you also don't have to. So you can just, because the one's on the bottom, you can just 2 divided by 1 is 2.
I just plotted 4, 4, and 5, 6, and found the slope and went down.
Yeah, you can do that. Yeah. Okay, questions? All right, now let's look at what we would do if we, actually no, I think it's one of the next ones. If I didn't make one of these, we might have to add one. I'm pretty sure it's on here somewhere though. All right, so this one, we don't have a graph. We also have numbers that are large enough it's going to be hard to graph even if we pull out the whiteboards, right? I guess we could scale it, but sometimes that's difficult. So, what is my y-intercept? Allison, what would my y-intercept be? This one. It is not 2. You're on the right track and looking for a 0. But it's not 2 because that's where my y is 0. It is going to be 40. So we're always looking for where x equals 0. And then that number that goes with it is going to be our y-intercept. So always look at the x column for zeros for when you're looking for y-intercept. Okay? So our y-intercept is 40. Okay? What is our slope here? Who thinks in a slope? Katie? It is negative 20. Because we are going down 20, since this is decreasing, it's got to be negative over here. And then our x values are going up by 1 each time. So my slope is negative 20 over 1, but of course that's just negative 20. Okay? So Laura, what is the equation if my y-intercept is 40 and my slope is negative 20? What is my equation? Perfect. Okay, questions? Okay, now let's look at this one. This one, numbers are too big to graph, and do I have a y-intercept on this? I could find it. Okay, if I don't have a y-intercept, then I need to start with slope, right? So Peyton, when I'm looking for the slope, nine, and then it's 9 again, 9 again here. Over here on the left, how much do I go up by? 1 all the way down. So what is my slope going to be? 9. All right, so what I've got to do is I need to know whenever x equals 0, I need to know what the y is, right? So you can squeeze this in on the graph if you can. I'm going to rewrite it. So I already know that 1 is 3, 2 is 12, 3 is 21, 4 is 30. So I've been adding 9 each time, right? So if I want to figure out what the 0 is, I got to go back this way. So what should I do? Okay? I'm going to subtract 9. And Easton, what am I going to get? Negative 6, right? So, so this, now because the x equals 0 right here, this is my y-intercept. So, y-intercept equals negative 6. So, whenever I do that, let's see, Caroline, what's my equation going to be? Yeah, just minus 6 will be more simple there. Perfect. Okay, so if you don't have a y-intercept on your table, you're going to have to fill in to figure out what it is. Okay, so I want you to try each one of these. When it says explicit formula, you may possibly see this. There are also recursive formulas, which for the last couple of years I have opted to skip, and we'll do it at the end of the year right before the exam if we get time. But an explicit formula is just your y equals mx plus b formula. Okay, so if you see that given to you, explicit formula just means to find y equals mx plus b. So I want you've got these on your slide there. I want you to try these four on your own. We got a worksheet. Okay. All right. So we got a couple worksheets we're gonna do. All right. So for this first one, you should get y equals negative 3x plus 5. I was seeing lots of you with that as I walked around. Okay. For example 8, you should get y equals negative 4x plus 6. On this one, you're going up, down by 8 each time. So it kind of makes it look like it should be negative 8, but you're going up by 2 over here. So you got to do negative 8 over 2. So we got these two. Questions on those first two? Alright, the next ones are harder. Okay, who can tell me my slope for this one? Jada? 19. So we're going up by 19 each time here, and this is just going up by 1. So 19 over 1. Alright, so you got to know where the x equals 0. That's not on here, right? So we got to think like this will be 1, and this will be 0, and we got to go backwards, right? So Easton, what are we going to do? Good, and that's going to give us negative 4, I believe. All right, and then that's not our y-intercept because that's where x equals 1. We got to do it again. What are we going to do when we get? What are we going to get when we do that? Negative 23. So we're going backwards by subtracting 19 each time, which is going to give us negative 23. Do we have the x-intercept for 10? Y-intercept. We don't have it. We actually do have the x-intercept. If I was meant to ask you that question. But that 0 right there, that is not our y-intercept because it's in the y column. So we don't have the y-intercept. We need to think about slope. We're going down 8 each time. Over here we're going up by 2. So negative 8 over 2, which is negative 4. There's our slope. So y equals negative 4x. We need to know what's going on here. So now we were going down 8 each time here, but we skipped a number, right? So like in between here there would be 2, and that would be 4 right there, right? And then here we got 4, and that would be negative 4. So really, like, since we skipped those numbers, we're really just subtracting 4 each time. If we add those extra ones in, which is where our slope comes in, right? So if I want to go backwards up here to the 0, what do I have to do? Got to add 4, which is going to give me 12. So I'll have a plus 12 for my y-intercept. Okay, questions? Okay, we got a couple things that we're going to do.